So this is count each letter. It's going to enter, prompt you to enter for something. It's going to count equals count letters, and it passes the entire string in there after converting it to lowercase. And in here, it creates an array. It returns an array of integers, which it will store up here. And it's 26 because it's 26 characters. And basically what you do is you're going to put in, using a for loop through the length of the string, if it's a letter, saying if character.isLetter, s.char@, in the index where we're at, counts, which is our array, sub s1.char@ -a. Okay, so if you remember, we talked about a while ago, we've done a couple examples on this, where a character is really an integer, and to get at its numeric value, or to get a numeric offset from it, you can just subtract the lowercase letter a or the uppercase letter a from whatever character you got, and that will give you a number. So, for example, if s.char@I is the letter A, and you subtract the letter A from it, then that's 0. If it's B and you subtract A from it, that's 1. If it's C and you subtract A from it, that's 2, and so forth. So that's what this neat little trick is doing. This whole calculation here is going to ultimately produce from 0 to 25. And it's going to increment it by 1. The integers here will automatically start with 0. So basically when you come in, and if this is an A, then it will automatically be count sub 1, because, I'm sorry, if it's a B and you subtract A, that's a 1. So counts will be count sub 1, and we add 1 to it. If it currently had 0, now the count sub 1 has 1. And if you get another B, it'll then be 2. Let's see, what does it say? And so now it goes through, and then the outer for loop I said Mary, oh yeah, D is there, so A is there 4 times, B is there once, D is there once, E is there once, H is there once, I is once, L is 3 times, and 1, 2, 3, yeah, so 3 times. So basically that's how that works, and it counts the characters. Any questions on this example? Okay, these next two are kind of synonymous with each other, string builder and string buffer. They're basically new and improved strings. The string is one of the earliest objects created in object-oriented languages, and it was kind of always designed to be a hybrid. So it's kind of got some limitations. The original one was the string builder, which was a better string, essentially, more flexible, better use on memory, mutable instead of immutable. And string buffer is yet an improvement on string builder. So mostly what we're going to look at is string buffer. String buffer has exactly the same methods and capabilities as string builder. It's just basically a newer version. Okay, so string builder, well, maybe we're going to use string builder. There's a couple of constructors it has for it. Nothing, which creates an empty string builder with a capacity of 16 automatically. Or you can create one with a capacity, which creates, again, a string builder with whatever your specified capacity is. Or you can pass in a string. And with a specified string, and it will construct it based on that. It's got a whole bunch of methods too. Append, which will append characters. See, the problem with the string is that every time you modify the value of a string, Java actually has to find a new location in memory for the new string if the string is bigger, because it's immutable, which means it can't just modify that memory. It's basically got to wipe it out and start over every single time. That's the way the current string works, and that's inefficient. String builder and string buffer actually allow you to modify the current memory, so it's definitely more efficient. It's got a bunch of methods. Some of the methods are similar to what you'd see in a string, and some are different. So we'll look at a bunch of these as well. Most of these have to do with appending, deleting, inserting, things like that, replacing. So we'll look at this now, and I'll give you an example of what I mean by the two different things. We'll see in a moment. Look at a couple of different examples. Let's get us a new. So we have to create these string builders first. String. Okay, so we probably should show what's in string builder after each change. And then the other thing, we'll look at this first, and then we'll look at what are the differences, what I mean by mutable versus immutable. Uh-oh, didn't like something. String index out of bounds exception 11, line 21. Okay, so you know what, we probably have to give this an initial value. So let's say, welcome to Java. Yeah, we just do that. Welcome to. Wow, that should be print line. So you can see all the changes that happen. So if we tried to do the same thing with a string, for example, and then I say system.out.println s, then I try to say s dot end Java, which you can do. Apparently it doesn't want to recommend. Okay, let's just do the the plus sign then. Okay, so it gives an error message, and it says not a statement. Yeah, it won't work. That actually will change it. Well, let's try something different. What do we have? Dot. Let's just try replace. Okay, so it works, and then let's print it out again. Let's go ahead and run this. Okay, so you'll notice that even though I said s.replace a with a, it's still lowercase. And why is that? Because the string builder will let you do replacements. And the reason is that this replace method doesn't replace the current string s. It creates a new string and returns that new string to something here. So I could say string s2 is equal to, and then we could print string s2, and you get s2 has the now uppercase A. And what we mean by immutable is none of the methods that you use from this original string change the current value. In every single case, they create a new string, and then you can assign that new string to a new string. Whereas string builder and string buffer always modify the existing memory, which is more efficient than creating new memory all the time. So string builder, in essence, and string buffer, which are really the same thing, are more efficient ways of working with strings. Particularly if you want to do a bunch of concatenation and things like that. Definitely more efficient. Does anyone have any questions? And it's got methods like substring, but again, returns a string. In this case, it does return a string. So you can set the length, get the length. So you've got a lot of the similar methods that you have with the string. We have another example of this. Does anyone have any questions on string builder, buffer versus string? It's basically just a better string. Palindrome, ignore non-alphanumeric. That's our second palindrome somewhere. long one. And so in this particular case, I think all it's doing is it's using the is if letter or digit. It's filtering out all non-strings basically. So what it does is it takes your input and prints it out. Calls is palindrome. Is palindrome, the first thing it does, it uses the two filters. And then it creates a new string by reversing the original one and just returns whether the two are equal or not. So that's another thing you can do. You just return it. So filter gets rid of the non-characters. It's using a string builder here now. And reverse is actually a reverse method of the string builder class. And one of your labs actually asks you to do the reverse. So some of these string methods, and I think that's on which lab is it? It's not 4 or 5. I think 6 wants you to do something like that. So you should be paying attention here on these things here, printed in backwards and things like that. And we can go ahead and run this. Now, so this time I'll enter Bob with a period, and it still says it's a palindrome because it filtered out the period. The other one would have said no, it's not. Another example, we talked. This is kind of getting away from strings, but this is talking about the main method. And we know that if we want to run something, it's always got to have a main method. But a main method is really just a method. It's a method that Java looks for specifically. But other than that, it's just a regular method, and you can invoke it. So one class can call the main method of another one. So, for example, if we go down to A and B, which I've got here, class B, which will use a for loop to print out everything that's passed in, and then A creates a string with all those values and simply says b.main. It's a static method, so it doesn't have to even instantiate it. It just calls it directly. So if we do this and we run this one, you get that. But the main method in B was called from A. And there's no reason why you can't do that, because it is a method. The only thing special about main is that Java knows to look for it. That's the only thing special about it. Other than that, it's exactly the same. I could come in here B and copy and paste this and call it Bob, and then in A say Bob. You get the same exact output. I mean, it's exactly the same. So the only thing special about main is that Java knows to look for it. Other than that, there's nothing special about it. It's just another method. That's basically what this is saying. Command line arguments. You can pass some of this stuff in from the command line. And in order to do this, we have to actually go out to the command prompt and do some of this stuff.